Look at this one. We are subtracting rational expressions, and they do already have a common denominator. You know, we can't add or subtract without a common denominator. So let's go ahead and put them together, all over one denominator. I have x plus 3, and I'm going to have 9 minus x squared. 9 minus x squared. Now you always want to factor completely, factor the numerator, factor the denominator, and then try to reduce. So the denominator is already factored, that's fine, x plus 3, but look at the numerator. Well, it's not in the right order, is it? I need my x squared first, then any x terms, and then my constant term. So let's change the order, let's rearrange this. It's going to be negative x squared plus 9 over x plus 3. Okay, remember that this negative is attached to the x squared, so it's negative x squared. And this 9 is positive, right? Do you see a minus out here? Nope, so it's positive. All right, now, look at my numerator. Now, when I move the x squared in front, it starts with a negative. I never want my leading coefficient to be negative, so what I need to do is I need to divide out a negative 1. Divide it out of the numerator, and I will be left with a positive x squared, and I'm dividing this by a negative 1. When you divide a positive by a negative, you're left with a negative. Now what do you see? What do you see? What's this? It's the difference of two squares. So I'm going to factor that, and I'm going to get my conjugates. Here's a negative 1. That just comes down. Let's do the conjugates. X squared minus 9 is x plus 3, x minus 3. Put it over the denominator. And now, you see anything that cancels out? Yep, this and this. All right, you're always looking to cancel out in that last step. Right? A lot of these problems are set up so that that happens. Now I have a negative 1 out in front. I have a x minus 3 all over what? Over 1. And I don't need to put anything over 1. Anything over 1 is just itself. So here's my answer. Okay, you don't need to distribute that negative 1 through. You can do it. It's okay. But we like to leave our answers in factored form when we're talking about rational expressions.